So today I decided to do some quantitative comparison problems and kind of walk you through how I do them. So that's what you'll see here. And I'm going to link the PDF that I used to find these problems. I'll link that in the description of the video. So if you want to follow along and practice them on your own, you can do that. This is an official GRE practice test that is not in one of the books, but you can find it online, and so that's what I used. It's written by the ETS people, and we have 9 problems here that we're going to work through together, and that will be that. So thanks for watching, and I hope it's helpful. Please remember to like and subscribe, and we will have more videos coming soon. So our first problem shows us 2 triangles. They're both right triangles, which we can see that little square there. And they both have one leg that is 4. So what we want to do is compare quantity A, which is x, this side over here, to quantity B, which is y, and it's this side over here. Now, immediately, there's a few things we have to keep in mind. This is not asking us what is the value of x or what is the value of y, just which one is greater. Is x greater than y? Is y greater than x? Are the two quantities the same, or do we not have enough information to determine this? Now, sometimes there's very ambiguous problems. We have to think through, is there actually a way to compare these two values? But in this case, I think it's going to be pretty straightforward because these are both right triangles and there's a lot of clues in the numbers that they've shown us of the legs and the hypotenuse that give away what kind of right triangles these are. So the first one on the left, I believe, is a 30, 60, 90 right triangle. And the reason that matters is because in a 30, 60, 90 right triangle, the side opposite the 30 degrees is some value, in this case 4, but let's call it V, right? So that's the side opposite 30. The side opposite 60 is always V root 3. And then the side opposite the 90, or the hypotenuse, is always 2V. This is the ratio of and relationship of the sides of a 30, 60, 90 triangle. So that means we can really easily see what x is. X is going to be 4 root 3. And I can just write that here too. All right. Now y is slightly different because the two legs of this triangle are both 4. If they're the same, there's only one type of right triangle that has its two legs the same, and that is a 45, 45, 90 triangle. So in a 45, 45, 90, we have the legs are equivalent, and the hypotenuse is whatever the legs are times root 2. So y has to be 4 root 2. And again, I'll write this ratio for a 45, 45, 90. It looks like this. It looks like V root 2. One trick I'll say, the way I remember the difference, because they both have a square root, one is root 3, one is root 2. The way I remember the difference between these two is that in a 30, 60, 90, there are 3 types of angles and 3 types of sides. So it has a root 3. And in a 45, 45, 90, there are only 2 types of angles and 2 types of sides. So it has a root 2. Anyways, let's put our y equals 4 root 2. And pretty safely, we can see that x is going to be greater than y, because even though root 2 and root 3 are both 1 point something, because we know the square root of 1 is 1, and then the square root of 4 is 2. So it's somewhere between 1 and 2, but root 3 is obviously a little bit bigger than root 2. So here we would answer A, quantity A is greater. All right, let's go on to the next one. So our next one, our information is algebra this time. And we see we have x minus 2y times x plus 2y equals 4. And the quantities we're comparing are x squared minus 4y squared and 8. Now, when I see something like this where there's squares in here and a negative in between them, subtraction in between them, it seems really likely that x squared minus 4y squared is what I'm going to get when I multiply these two quantities together. And one of the reasons that it's one of the things I know about multiplying, or the difference of two squares is really what this is called, is that they're always going to have two terms that cancel each other out in the middle. So when we factor this, we're going to see that we're going to do negative 2y times x, and we're going to do positive 2y times x. And so that will be 2xy minus 2xy. So those are going to cancel out. So the only terms that we really care about here are the first x times x, which gives us x squared, right? This x squared right here. And then negative 2y times positive 2y, which gives us negative 4y squared. So that is how we simplify. Quantity A is the simplified version of the left side of this equation. And we know x squared minus 4y squared equals 4. And 4 is less than 8. So quantity B is greater. Awesome. Next one. A certain recipe requires 3.5 cups of sugar and makes 2 dozen cookies. Then we have quantity A, the amount of sugar required to make the same recipe for 30 cookies, and quantity B, 2 cups. So here we have 2 dozen cookies, which is 24, right? And it's not that much more to get to 30. So I already have a hunch that 2 cups is going to be too much sugar because this is only 1.5 cups, right? So a whole half cup to make 6 more cookies seems unlikely, but let's actually do some math here. So I am going to set up a ratio, and I'm just doing 1.5 because it's easier to set up a ratio when we have that, which is that I know 1.5 cups of sugar for every 24 cookies is going to equal unknown amount of sugar for 30 cookies, and we cross multiply. So we have 1.5 times 30, which is 45, equals 24x, and x thus equals 45 over 24. At this stage, because I'm not using a calculator right now, I'm trying to, as I've mentioned in other videos, the GRE calculator is horrible, so every place where I can avoid using it, I try to do so. And so here I see 24 into 45 is going to be less than 2 because 24 times 2 is 48 and 45 is less than 48. So I can see that my hunch was right and 2 cups is greater than quantity A. But if you wanted to do that and know for sure, we can just calculate that right now. 45 divided by 24 is 1.875, which again is less than 2 cups. All right, our next one, I think this one is a really good example of a quantitative comparison question because we finally have some really extreme ambiguity that makes these problems difficult, I think. So we have the given information tells us that a power station is located on the boundary of a square region that measures 10 miles on each side. So I'm going to draw our square region. That's supposed to be a square, don't worry about it. And we know that each side of the square is 10 miles. And there's a power station located on the boundary. So I have to remember right away that, let's just get like pink, sure. Okay, the power station could be anywhere on this boundary. It could be here, it could be here, it could be here, it could be here. You get the gist, it could be anywhere. Okay, so that right there is a lot of ambiguity and a lot of unknowns in this problem. Then we are told that 3 substations are located inside the square region. So we know we have 1 on the outside and 3 somewhere on the inside. So those could be here, or they could be in any other place inside that square region. So if we are, of course, we want to compare 30 miles, or as a random thing, quantity B, but quantity A, the sum of the distances from the power station to each of the substations. So that means that if we need to know where the power station is, and then how far it is from each of the substations, and add those together, and then say, is that more or less or equal to 30 miles? So in a situation like this, I'm going to see if I can find a few different scenarios and how they affect this whole thing. So I just erased it, and I'm gonna draw a new square because I want to try scenario 1. Scenario 1 is we have our power station on this corner right here, and then I'm going to put one substation as far away as it can possibly be over here, and then one really close and one in the middle, let's say. Why not? So knowing that this distance is 10, that means that both this station 1, let's call it, and station 2 are going to be less than 10. So let's call station 1 is 1 mile away, and then station 2 is, let's say, 4 miles away, okay? But the thing about station 3 over here is I put it on the diagonal line all the way across from our main power station. And because within a square, the only line that's longer than the perimeters of the square is the diagonal line, both diagonals of the square. The diagonals of a square are always going to be the length of the side times root 2. So the diagonal is 10 root 2, which means 3, if it's not all the way at the opposite corner because it's not on the boundary, it could still be 10, or it could be 10 times root 2 is going to be something less than 20. So let's say it's 19. All right, so right there we have 24, and that is less than 30. But of course, in order to choose A or B, in this case, we would be choosing quantity B is greater, right? If this is our answer. But it has to always be true. Quantity B has to always be greater. So now that I did that, I want to see if I can figure out a scenario where quantity A would be more than 30. So in this situation, I'm going to put the power station on a corner again, and I'm going to put all 3 of the power substations on the opposite corner. So in that case, if each of them are 19, 19 plus 19 plus 19 is clearly more than 30. That is, what's 19 times 3? Okay, come on, brain. 57, all right? Now, the reason that I wanted to do this is because if B is not always greater, it can't be the answer. A is clearly not always greater. We saw that as well. The two quantities are not equal, so we're left with D. And that's this ambiguity, going into a problem like this, I probably would have chosen D to begin with. But it's not always going to be the answer just because a problem is ambiguous. Sometimes there is a really clear way to find a comparison or a true relationship between the two quantities. But let's move on and see if the next one will give us that. All right, here we have some quantity x that's in between 6 and 7, and y equals 8. So in a case like this, x could be 6.1, right? Or x could be 6.9, and everything in between. So y we always know is 8, okay? And let's see what happens. I mean, this is a similar kind of ambiguous situation where we need to see what's going to happen. if we do 6.1 divided by 8, and that is 0.7625, which is smaller than quantity B, right? How will that change if I do 6.9 divided by 8? Let's see what happens. And I'm using my calculator to do this, but it's just not showing on the screen. So don't worry. In this case, I don't know how to do that just off the top of my head. And this time it's 0.8625, which is greater than 0.85. So here's a faster one, but a great one to show that, again, we don't have enough information to determine the relationship between these two. And I think the key takeaway here is that when you have a quantitative comparison and you're going to be using numbers that seem possible from the given information, it's a good idea to go extreme. Here I chose the smallest number I could easily put into a calculator and the largest number I could easily put into a calculator, so that I could quickly see what happens when the numbers change like that, and then I was able to get to D really fast. I mean, because someone could do 6.1 and then 6.2, and those would still both be smaller than quantity B, and that's not enough. You need to always look at the extremes when you are trying to deal with a quantitative comparison, because basically we're trying to always say, is quantity A always greater? Is quantity B always greater, right? And to know that with something that has a range, we need to look at the extremes to see what happens. Okay, next one. 0 is the center of the circle and the perimeter of triangle AOB is 6. So if 0 is the center of the circle and triangle AOB clearly has 2 radii here, right? And the perimeter of the triangle is 6, so we need to figure out, are all 3 sides of the triangle going to be the same? And we know that they are, because this angle right here is 60, an equilateral triangle. All the angles are 60 degrees and all the sides are equal. So if AOB is 6, we have to do 6 divided by 3 is 2, so each side of this is 2, which is great because quantity A wants us to tell them the circumference of the circle, and all we need is a radius for the circumference of the circle. Circumference is 2 pi r, so in this case, 2 times the radius is 4 pi, versus quantity B, which is 12. And I know that that means quantity A is going to be greater because pi, we don't need to know this by heart, but pi is greater than 3.14159, dot, dot, dot. And 4 times 3 equals 12, so 4 times 3 point something is going to be greater than 12, so quantity A is greater. All right, we just have a few more of these, so let's keep going. Now this one is a data problem, which is kind of different. That's fun. So we have quantity A, the standard deviation of a set of 5 different integers, each of which is between 0 and 10. And quantity B, the standard deviation of a set of 5 different integers. So both of these we have different integers, each of which is between 10 and 20. So this right away, I see that because the numbers are changing, this one, quantity A is between 0 and 10, quantity B is between 10 and 20. Our instinct might be to say, okay, the standard deviation is going to be greater in quantity B. But remember, standard deviation is not the average. It's the distance each actual number in the set is from the average. So, and there is a formula for standard deviation. I don't think we need that formula here, but we do need to remember, if for quantity A, the average of the set is 5, if, I'm just making this up, but if the average equals 5, then the standard deviation is going to be, okay, let's look at the set. The set is 1, 2, 7, 8, 9. Okay, I know this one doesn't actually have an average of 5. I'm just making this up right now, but just to illustrate the point is that to find the standard deviation, we would have to say how far is each number in the set from 5, and then we add that all together. So I see right away that there are just so many different options here because you have 5 integers, but there are 11 different numbers that could be in the set. But let's just try an example just to see what happens, just so we can kind of figure out where we might be looking when it comes to the answer. So quantity A, the standard deviation of 5 different integers between 0 and 10. So I'm going to pick my set is going to be 0, 1, 2, 3, and 4. All right. So our average here is 5 plus 5 is 10 divided by 5. So our average is 2. So our standard deviation is going to be something like, and this is not exact because I don't want to use the formula because it's very complicated. So let's just say, oops, what just happened there? Sorry about that. All right, so let's just say our standard deviation is going to be, one of the numbers is 2, right? And 1 is 1 away from 2. That's 2 away from 2. So 1, 2, 0, 1, 2. So our standard deviation is somewhere in this like 3, 6, square root, whatever. Okay, and let's compare it to quantity B. I'm going to take, let's say we'll do 20, 19, 18, 17, and 16. And let's take the average here. So 20 plus 19, 90 divided by 5 is 18, so our average is 18. And that makes sense that we did all the numbers in order, so the middle number is going to be the average. And in this case, so our average is 18, so we're going to have a very similar situation where we have this one is 1 away, this is 2, this is 1, this is 2. So here the standard deviations are going to be the same. You can already see how that might change as soon as we do a different difference between the numbers, right? Like if we did quantity A, we said the set was 0, 5, 6, 8, 9, right? And then quantity B stays the same set. Like let's just look at this right click. 0, so 5 and 6 is 11, 8 and 9 is 17. 17 plus 11 is 28. 28 divided by 5, let's do that. 5.6, okay, so the average is 5.6. So let's look at the difference. This is 5.6, this one is 0.6, this one is 0.4, this one is 2.4, and 3.4. So you can see that in this case, this standard deviation is going to be greater than that standard deviation. So this is a great time to also choose D, where the relationship, it's not enough information, which also tells us the relationship changes based on different choices we make as we're testing out options for this problem. All right, cool. So we are going to move on to the next one. X is greater than 1 is what we're told here, and we have quantity A is x times x squared to the 4th versus x cubed to the 3rd. So x times x squared to the 4th, let's simplify that. X squared to the 4th, we multiply when we're taking a exponent to an exponent, so it's x to the 8th. So we have x times x to the 8th. And when we multiply same base, different exponents, we add the exponents together. So that means this is x to the 9th. Quantity B, x to the 3rd to the 3rd, we multiply 3 times 3, so that's x to the 9th. That means these two quantities are equal. It's nice to have a kind of really complicated one followed by a really straightforward one. So perfect. And now our last quantitative comparison from this practice test is here. X does not equal 0, great. And quantity A is the absolute value of X plus the absolute value of negative 2. Quantity B is the absolute value of X minus 2. So let's choose some numbers here. And again, remember, we need to think extremes. So I'm going to test out two different versions. I want to try X equals negative 4, let's say, and then I'm also going to try X equals 1. And let's see what happens. So first with negative 4, the absolute value of negative 4 plus the absolute value of negative 2 is going to equal 4 plus 2, which is 6, versus the absolute value of negative 4 minus 2. Negative 4 minus 2 is negative 6. The absolute value is 6. In that case, they are equal. Let's see what happens when x equals 1. So I'll do this above here. So we have the absolute value of 1 plus the absolute value of negative 2 is going to equal 1 plus 2 is 3. The absolute value of 1 minus 2 is 1 minus 2 is negative 1. The absolute value of negative 1 is 1. So in this case, A is greater than B. So because one time we have a greater than and one time we have an equals, we have to choose D.